All right, we're going to deal with a system of equations and do some basic operations with the system of equations to get us working with matrices. First, we're going to solve this system of equations two ways using algebraic methods, and then we're going to solve it using two matrix methods and the calculator. So these methods that we're going to do now are the ones that you might learn in an Algebra or Algebra 2 course and are sort of a preliminary connector between the algebra and the matrix methods that we're going to be learning. So if we have a system of two equations with two variables, we can solve it algebraically by substitution, and we can also solve it by elimination, which will be the second thing that we do. To solve by substitution, we need to isolate one of these variables, get it by itself, and then substitute the expression that is equal to that variable into the other equation in place of that variable and solve the resulting equation. I'm going to solve for this y because it's got a -1 coefficient, which is pretty easy to take care of. So I'm going to start here. First of all, I'm going to write this equation over here to the side. So I have 2x minus y equals 14. I'm going to subtract 2x from both sides to get it over to the other side. So now what I have is -y on this side equals -2x plus 14. And I have to divide everything by -1 to get rid of this negative sign. So -1, divide by -1, divide by -1. And what I get is this turns into a positive y equals, this is a positive 2 coefficient here, so positive 2x. And over here, this turns into a -14, so minus 14. So I used this equation, so now I'm going to use this equation, 3x plus 7 times y, but I have a new expression for y, equals -47. And the expression I'm going to put here is 2x minus 14. And then I have an equation that only has x in it. So now I have 3x plus, I have to distribute the 7. So I have 14x minus 7 times 14 is 98. So I have minus 98 equals -47. And I have 3x plus 14x, which is 17x, minus 98 equals -47. And now I have to add 98 to both sides. So I have -47 plus 98, which is 51. And I get 17x equals 51, and I divide both sides by 17, and I'll get 3. Let me see if I can. Yeah, get that a little bit easier to see. All right, so x is equal to 3. But I also know that y is equal to 2x minus 14, and I know x now, so y is equal to 2 times 3 minus 14, and 2 times 3 is 6, minus 14 is -8. So the solution here, I know that x is 3 and y is -8, so the solution is 3, -8. And I can verify that by plugging the 3 and the -8 into both of these equations, and I'll find that that satisfies both of those equations. So we know this is the solution. The next thing we're going to do is we're going to solve this same system. Now that we know the solution, it's easy to check. And we're going to solve it using the elimination method, because this is the method that's going to most directly connect us to the matrix methods that we'll use in that next portion. So the theory behind this is that you can multiply one or both of the equations by something that will make one of the variables add up to 0 when you add the equations. One of them will drop out. Now this is a +7 and this is a -1. So if I multiply this second equation by a 7, I'll have a negative 7 here, and when I add it to this positive 7, the y's will drop out. So I'm going to multiply this times 7, and I'll get 14x minus 7y equals 7 times 14, which we had that up there. It's 98. You see a lot of the same numbers because we're working with the same equations. And then this equation is 3x plus 7y equals negative 47. So 3x and 14x makes 17x. This should look kind of familiar. 7y and negative 7y makes a 0, so that drops out. And negative 47 and 98 is, again, 51. We found that out previously. So again, this should look familiar because we're solving the same set of equations. And when we divide by 17, we find that x is, again, 3. And now we have to go back to one of our earlier equations. It's not quite as simple as it was back here, plugging this 3 into this equation. But we have to go back somewhere where we still had two variables, and I'm going to use this one right here. So 2x minus y equals 14. If x is 3, we have 2 times 3 minus y equals 14. This is, again, 6 minus y equals 14. And I subtract 6 from both sides, and I get negative y equals 8. And if the opposite of y equals 8, when I divide both sides by negative 1, I'll get y equals negative 8. So we have, again, 3, negative 8. And that's the same solution we got before. So now we've gotten that solution 2 times using 2 different methods. And now we're going to do that same thing with matrices. So we're going to use 2 methods, and these are the 2 that you'll be asked about in the assignment. We're going to solve with using a matrix. We're going to solve by getting the matrix into reduced row echelon form, or RREF. And then in the second matrix method, we're going to solve by using the inverse of the matrix. So the matrix here, notice the x's and y's are just kind of the same here, but what's different are the coefficients and the constants. So this would turn into a matrix where we just take the numbers and we don't write the variables because they're the same every time. In order to use the reduced row echelon form to solve this, we need what we call an augmented matrix. And this is easy to put into the calculator. When we write it, it looks like this. We take the coefficients of each of these. So we have 3, 7, and then because the negative 47 is on the other side of the equal sign, we put it on the other side of this line. And then we use the 2. This is a negative 1, and this is a 14. And those are the numbers, if you noticed in the previous 2 examples, we were working with those numbers. The x and the y were just the things we were finding values for, but we didn't really do anything with them except sort of take them along. So now, if we put this into the calculator, we can use a function on the calculator under the matrix operations that allows us to simply find the solution very quickly. And I'm going to go through how to enter this into the calculator. First of all, the matrix functions are right here they're the second function above this x inverse button, x to the negative 1. So this is the matrix functions. So we do second matrix. We want to edit a matrix. And this is a 2-row, 3-column matrix, 2 rows and 3 columns. So this is a 2 by 3. So I'm going to choose A, and I'm going to edit it. I'm going to make it a 2 by 3. And then I'm going to put these numbers in. Now this doesn't have the line for the augmented matrix, but the calculator knows what it's doing. It doesn't have to have that line. So I'm going to put in the 3, enter, 7, enter, negative 47, enter, 2, enter, -1, enter, and the 14, enter. Now I have these numbers in my augmented matrix, and to get out of this screen I'm going to quit, which is the function right above the mode button. So I do second quit. I don't want to clear the matrix, I just want to get out of that screen. And now I'm going to go back to my matrix menu, so second matrix, and now I want to do math, and I'm going to go down the list until I see RREF. And there's REF, and this is RREF. So I'm going to choose that. And then I need to go back and retrieve this matrix because I want it to use this to find the reduced row echelon form. And so I'm going to do second matrix, and now I just get a list of them. And this is in matrix A, which is number 1, so I can just hit enter, or I can hit number 1, either one. And I close the parentheses, and then I hit enter, and it gives me the reduced row echelon form, which is this part. And then over here I have my solutions, 3 and -8. So what this tells me is 1x is equal to 3 and 1y is equal to -8. So it looks like this. And this is the x column, this was the y column. I had them in the same order. And so this says x is 3 and y is -8, which is the same result we got solving it the other two ways. The last way that we're going to look at solving this, and by now we certainly know the solution, is we're going to use the matrix again, but we're going to use a matrix of just the coefficients. This is the coefficient matrix, and we're going to put that in one matrix. And then we have the matrix with the constants, -47 and 14. And this is the constant matrix. Now, the matrix that would be between them would have the x and the y in it. So we have a matrix here that we would just call x for the variables. And if we look at this as an equation, this times that equals this matrix, and we can solve for this all at once by multiplying both sides of the equation by the inverse of this. So this is matrix A, and A inverse is what we want to multiply by. So we have A times x equals the constant matrix over here. And we're going to multiply both sides by the inverse of this. So we want A inverse times A times x equals A inverse times C. And that's also very easy to do. We have to put it in a little differently, but it's still easy. So we're going to go back to our matrix screen. And this is a 2 by 2 matrix. So when I choose A, I'm going to go over to Edit and choose A. And I want to put in a 2 by 2 matrix. And I want these numbers in there. Now notice, because this is part of the matrix I had in there before, it's already got the 3, the 7, the 2, and the -1. So that's what I want A to be. So I'm going to quit there. And then I'm going to come over here and put this matrix in. Now this is a 2 by 1 matrix because it's 2 rows and 1 column. So when I go to this, I'm going to go down to B, and I want to make a 2 by 1, and I'll put in -47 and 14, and then I'll quit from that. And now I want to find the inverse of this, and the inverse of this I can find using this x to the -1 key. That's the inverse key. So I do second matrix. I choose that matrix, which is number 1, and I just hit this inverse key, and we get the inverse. Now, that looks all complicated. We can make it a little bit easier sometimes by turning it into fractions, but we don't need that. All we need to do is multiply that by the matrix that we put in for the constants. So I'm going to go back and do second matrix A inverse times second matrix. Now the matrix that I want for the constants is matrix B. So I go down to 2 and choose that. And when I hit enter, I get the solutions, 3, -8. So my solution is the same no matter how we work this. We did 2 algebraic methods, we did 2 matrix methods, and we got 3 and -8, 3 and -8, 3 and -8 every time. So those are methods that you're going to be asked to work on in the homework. Make sure you watch the videos that go along with it, and that you can find all of those things on the calculator.